Hey guys, it's been a while since I made a video, and we just got a touch probe for the mill so that I could swap out fixtures and stuff and stop taking like 5 to 10 minutes getting a fixture zeroed and use a touch probe macro. So we're centering up our touch probe. The problem with these touch probes is that they don't come centered, and you'll check your touch probe up in your tool holder and this tip will be out around. Right now it's loose, I don't have it tightened, but what we're going to do right now is center our touch probe using this digital indicator. So we got our touch probe calibrated. There is a little bit of an issue. The peg that holds the probe itself is not only out of line with the body, but it's out of square. There's like a little kink in it. So while the center of the probe, the ruby ball may be centered, the shaft that holds the ruby ball is like, moving around in an arc. And I'm wondering if I go to reach past the kind of the Z-plane of the workpiece, that rather than the ruby ball striking the workpiece first and indicating a touch, that the shaft will hit. So I don't know, I gotta run some tests. That did not do well. Here are those parts I was talking about. These are flanges that go on the intake side of a vintage Porsche race car. I'm not really sure what model, but I guess the carb tubes or intake runners get welded to these collars, and then the carb mounts somewhere up here. And I got one coming off in just a second. It's kind of hard to see the part because I have so much light, but this is essentially what it is. Let me blow it off. So that's an intake flange for a Porsche. Not sure what model or year. Okay, I am super excited because I just set up rigid tapping on my machine. For those of you that have been watching my YouTube videos for a while, you know that this is something I've been working on for a long time. I had to do a bit of rewiring. The spindle was initially under the control of the PC, and it was initially under the control of the PLC, which controls the tool changer and used to control the spindle, because the spindle control and the tool change control were kind of needed to be very well connected because of the way the tool changer works. So I had to unplug the spindle from the PLC and plumb it into the CS Labs motion controller, which was a little bit of a headache because in the end I had to reprogram the tool changer operation, which was kind of a lengthy ordeal. Because I'm not really savvy with Visual Basic. But all that's done. I've actually already tapped a few holes on the machine, so it's doing its thing and it's doing it well. What we're working on are these stands. I got another order of these. This hole right here is an M25 1.5 thread. Before I was just thread milling them. Thread milling is great because you can adjust more of the parameters. It's kind of infinitely variable, so to speak. But we don't need something that sophisticated for this hole right here. It's just a really simple hole where an electrical connector screws in there. We need speed above all else, and thread milling is not as fast as rigid tapping. So I have 8 of these legs to do, and the machine is set, programmed, and ready to go, and I'm going to show you how well it's working. So we're going to cut our hole with a 3/8 end mill. It's just going to plunge down to the material and then cut a hole out. And then we have our tap up here. Big tap. See how she does. Give us some Z clearance here. Cutting the hole now. Got the tap loaded up. Here we go. Wow, that's awesome! This is the connector we're using. Oh, that's so perfect. I love it!